In today's lesson, we will be solving systems, but this time we're solving them by a method called substitution. So same thing, solving systems, which means what we're really solving is we're trying to find when two linear functions intersect. And we've already learned how to solve them by graphing. You graph both, find the point in which they intersect. But today we're solving by substitution, which is an algebraic way that we can solve systems without having to graph them. So the goal, or the steps that we will follow to use substitution, we're going to substitute one equation into the other, because remember, a system means two equations. After you substitute one in for the other, it means that you only have one variable left and you're going to solve for the variable. And let's say you end up solving for x. Your solution is always, remember, a point where you have x and y. So substituting one equation in will allow you to solve for one of your variables, and then whatever you solve for, you have to plug it back into one of the original equations and solve for the other variable, because every answer has an x and a y. So here we have a system of equations, y equals 2x and y equals 7x minus 15, and we have to substitute one equation into the other. But I'm just going to take a quick break from those equations, and I just want you to think about, what if you have y equals 4 and then y equals 2x plus 1, and this just goes back to basic substitution. If y equals 4, you're going to plug in 4 for y. 4 equals 2x plus 1 and solve for x. So go back to, we have a system, we're going to use that same idea. If y equals 2x, you can plug in 2x in for y, because that's what y equals. So if you rewrite this, 2x equals 7x minus 15. Substituted one equation in for the other, and now you can see that there's only one variable. We only have the variable x, and we're going to solve for x. So subtract 7x on both sides. Negative 5x equals negative 15, and then divide by negative 5. So x equals a positive 3. But that's not our final solution, because every solution has an x and a y. So to find the y, you can choose either of the original equations, and it doesn't matter, and you're going to plug in 3 for x. So if we choose the top one, y equals 2x, but x equals 3, 2 times 3 is y equals 6. And for this first example, I'm going to show you in both equations so you can see how it works for both. So y equals 7 times 3 minus 15, which is 21 minus 15, which is 6. So whichever equation you use, it doesn't matter, you will get that y equals 6. So your actual answer is the point 3, 6. So if you were to graph those two equations, they would intersect at the point 3, 6. Alright, so our next set of equations, they're not in slope-intercept form, but they're both solved for x. You have x equals negative 2y plus 1, and x equals y minus 5. And we're going to substitute one equation in for the other. Because x equals negative 2y plus 1, we can substitute that in for the x in the other equation. So you're going to now rewrite this equation with the new substitutions in. So instead of x equals negative 2y plus 1, and that's equal to y minus 5. So when you substitute one equation in for the other, it narrows it down to only one variable, so we solve for that one variable. So we have to get our y's onto one side, so we can subtract y and subtract y. So negative 3y plus 1 equals negative 5. And then subtract 1. So negative 3y equals negative 6. And then divide by negative 3. And y equals a positive 2. So you substitute, solve for the one variable, but now we have to find x, because every answer has an x and a y. So you get to pick whichever one of these equations that you want. I would say the second one looks a little bit easier, so let's use that one. X equals, instead of y minus 5, y is 2, and 2 minus 5 is negative 3. So after you get x and y, in this case our x is negative 3 and y is 2, remember, you can always check your solutions. You could either go back and graph these two equations and check if they intersect at the point negative 3, 2, or you can plug them in. So go back to your original equation, x equals negative 2y plus 1, plug in negative 3 equals negative 2 times 2 plus 1, negative 3 equals negative 4 plus 1 is negative 3. So it checks for the first equation. Let's try the second equation. X equals y minus 5. Plug in x equals negative 3 and y equals 2. 2 minus 5 is negative 3. So because it works for both, we've just checked that this is the correct solution. Alright, for this example, I want you to write down the system and then pause the video and see if you can solve it on your own, and then come back and check your answer. You should have gotten the answer 3.2 and 3.6. The next few examples, we're doing the same thing except the systems are set up differently from the start. So we still want to substitute one equation in for the other. However, in this case, we have one of them in slope-intercept form, however the second one is not. But what we can do is take the equation that is in slope-intercept form. This is saying that y equals negative 2x plus 9. We're going to plug that in for y. So I'm going to rewrite this top equation, but I'm going to have the bottom equation substituted in for it. So I have 7x minus 8y, but y equals negative 2x plus 9, and that equals 112. So now I need to solve for x. So this is just a multi-step equation that we're going to solve for x. I'm going to distribute negative 8. So 7x, negative 8 times negative 2 is plus 16x, and negative 8 times 9 is negative 72, equals 112. And now combine like terms. So 7x plus 16x is 23x minus 72 equals 112. Add 72 to both sides. So 23x equals 184. And then divide both sides by 23. And you get that x equals 8. So we have half of the solution. We still have to find y. But this is pretty easy because all you have to do is plug in x into the equation that's in slope-intercept form, because it's y equals negative 2x plus 9, and you just have to plug in 8 for x. So y equals negative 2 times 8 plus 9. So y equals negative 16 plus 9, which means that y equals negative 7. So the solution, the two linear equations, will intersect at the point 8, negative 7. Okay, let's use the same idea in this next example. The equation that is in slope-intercept form, it tells you what y equals. You're going to substitute that in for y. And then we're going to rewrite this equation. So we have 3x minus y, but y equals 3x plus 7. And then equals 4. So now we have to distribute this negative sign. So 3x minus 3x minus 7 equals 4. If we combine like terms, 3x minus 3x cancels out, and it leaves you with negative 7 equals 4. Well, if our variables cancel out and we get something that doesn't make any sense, that should hint at the fact that there is no solution to this system. That means that there is no point in which these two lines intersect, and if they never intersect, it means they are parallel. And if you go back up here, they're parallel because this has the slope of 3. And then the second equation, if you solve it for slope-intercept form, it's also going to have the slope of 3. Alright, our very last example, solving systems using substitution. I will get you started, and then I want you to try to finish this one on your own, and then you can check your answer. So find the one that is in slope-intercept form, plug it in to the other equation, and then you're going to rewrite this equation with the top one substituted in. So negative 4x plus y, but y equals 2x plus 10, and then it's all equal to negative 8. So from here, pause the video, and I want you to solve the rest of it on your own, and then check your answer. So you should have solved that x equals 9, and then plug 9 in for x to solve for y to get that y equals 28. Therefore, those two equations, when you graph them, will intersect at the point 9, 28. So there's your full lesson on solving systems using the method of substitution. You've seen when both equations are in slope-intercept form and when only one equation is in slope-intercept form. But always remember, your final answer is a point with x and y, and remember, you can always plug your answer back in and check it. So, good luck with the lesson.